Guys, today's part 3 of our design and build for home theaters. Today we're actually in the Experience Center location for Gramophone, located in Timonium, Maryland. And today I have a special guest with me, one of my favorite people over at Gramophone. I got Gabe Montemurro, our senior system design engineer for Gramophone. He's touched everything that Gramophone has put as far as home theaters, media rooms for the last 20 years plus actually. Gabe, we're in a beautiful space here over at 8 West. This is the Experience Center. Tell me a little bit about this home theater that you put in.
Thanks for inviting me today, John. This is one of our newest home theater systems that we've installed at Gramophone. It is a 7.2.2 Sonance Invisible theater system. We are in front of this 85-inch Samsung frame TV. The front end of this room is driven by Marantz preamplification. We use the Sonance DSP amplifiers to drive their invisible speakers, and the room is controlled by Control4.
Excellent. And we're also adding Kaleidoscape, which is a very big part of what we're doing for home theaters as well. Stay tuned. We're going to have a lot more questions on how to build the electronics and specifications for your home theater. Gabe, the first question is, what do you do here at Gramophone?
My primary role at Gramophone is documentation of audio, video, and networking installations, but I also work with the sales staff and the design and build team during the design process of a home theater.
All right. That seems like a lot of stuff. When we're designing and building a home theater, what kind of approach do you have when we start that process?
So we take into account everything that the client has asked for and their expectations of this home theater, and we start working through this linear process. But what happens is, it seems like it's linear, but what happens is we make decisions along the way, and we need to kind of circle back and reevaluate some of those earlier decisions we've made, whether it's something that the sales staff has brought to the table or something that design and build has brought to the table. So we'll walk our way through that process, constantly reevaluating every decision until we get to the end and we have the home theater that the client has expected.
So when we get to the process, through the process, and we start deciding on what products we want to select, audio, video equipment, speakers, subwoofers, projectors, screens, all that is encompassing of what you're doing in engineering. Is that correct?
That is correct, yes.
All right. So how do we start that process? Like, what does that look like?
So generally it starts with a consult between the sales staff and the client, and then they'll kind of do a query of what they're looking for in this room. Is it a dedicated home theater? Is it just a media room for use with their family? And they'll bring that information back. We'll walk through it, bring the design and build team in, and then try to evaluate how we can bring that final request of what they're looking for in that home theater to fruition.
So I know when we talk a little bit about home theaters, there's so much different stuff out there. You got 5.1, you got 7.1, now we have Dolby Atmos, which is 7.1.2. What does all this nomenclature really mean?
So traditionally we would have done home theaters in a 5.1 or a 7.1, and what we talk about there is it's a something dot something and X dot Y. And we talked about those primary speakers that go in that listener level layer. Now with these immersive home theater systems that you mentioned, like Dolby Atmos, we've added this three-dimensional layer, this top layer. So now we've gone from an X.Y to an X.Y.Z, and that .Z is the top speaker or the height speaker. And that takes us from this flat kind of surround experience where the speakers are all at ear level or eye level, and adds a height component to make it three-dimensional.
And when we're doing these systems, how often do we want to be inclusive of those height speakers?
As often as possible, we want to add a height component to the system. We will even sacrifice some of the listener level speakers to get a height component into the room, so we can take it from that flat disc to that three-dimensional experience.
And then the next question is, subwoofers, are they important? Are they needed?
Absolutely. You cannot do most home theater systems without a subwoofer. Traditionally, most of the speakers we use as the primary listener level speakers, they don't go low enough in frequency. So we have to bolster those with the subwoofer. And so you need at least one in a system. But what we'll often find is that in order to get uniform bass experience in a room, we need to put multiple subwoofers in there, 2, 3, 4, etc.
So we really could have 4 subwoofers in a room.
Absolutely.
That's pretty amazing. That's pretty amazing. How important are the front 3 speakers? The ones that are giving us the voice and the effects?
They are the majority of your experience in that system. Most of what you're going to find is going to come from that front field and come at you. What we're doing with the rest of the speakers is just kind of filling in the acoustic environment.
Excellent. So do we ever see people buy better quality speakers for the front and maybe lesser quality for the rear?
Yes, it happens quite a bit, and part of that is many of our clients use this not just as a home theater, but they also use it as a music listening space. So they'll take those front left and right speakers and sometimes the subwoofer, and take those to an elevated level so that when they listen to music in that room, they have the ultimate experience, and then fill in the rest, generally with the same manufacturer, but not all the time.
Yeah, so you guys heard it first. You could also make your home theater a really good listening room as well. So sometimes we're given a space and the customer may not know if they want to do a television or a projector. At what point do we think a projector is the right solution?
So sometimes we look at the space and it's a question of how do they want to use the space. They want to use it as a media room where they're going to have maybe the lights up, less specific theater seating in that room. We'll just go to a large flat panel, like 100-inch or so. Just a few years ago, 100-inch would have been a projection system, but now we're going much larger with projection. So if they want a dedicated home theater space, then we'll start talking about a front projection system.
So with front projectors, are we limited to size? Can we pretty much do the full wall of that front space?
Absolutely, we can just take the whole front wall and fill it with an image.
Excellent, excellent. So that's more like a movie theater.
Correct.
Okay. And now we talk a little bit, you see televisions that are 16 by 9, and then you see some screens that are 2.4, 2.35. Can you tell us a little bit about what that means and what that actually is for the consumer?
Yeah, absolutely. So when we talk about our flat panel TVs, that 100-inch theater we talked about, you're going to be fixed at that 1.78 or that rectangular aspect ratio. But when you watch movies on there, sometimes you might notice that the movie goes across the center of the screen, but you've got these bars at the top and the bottom. Well, when we do a projection system, and we can do a 2.35 or a 2.4 screen, we can basically take and mimic that size. So those bars basically disappear and we fill that whole image.
So how often when we're doing these screens can we put speakers behind the screen?
So oftentimes as the screen gets bigger, it basically necessitates that we're putting those speakers behind the screen because we simply don't have the real estate on the wall any longer to put those speakers outside. Also, if we put the speaker behind the screen, you're basically locking the audio and the video together. So those voices come straight at you. Those sounds that are on the right and left of the screen come right through the screen.
And through your engineer process, I know we have people that come out and we measure the space. We make sure all these things are done. Do we have like sight lines or anything put in place through that engineering process?
Yes, what we'll have is the design and build team will draw up your room three-dimensionally so we can see it from above, we can see it from the side. And what we'll do is we'll put that screen on that wall to give you a sense of how much of that wall is being taken up, what is it filling, and then where are you sitting. Also, it's very important that we understand where the screen and the projector are going to be in relationship to one another because there's a specific relationship between those two and it creates the distance between the screen and the projector.
In the world of technical terms, that's called throw distance. So there's a mathematical equation that we could probably figure this out with.
Correct. So for every projector, we have a minimum and maximum throw distance calculated.
Yep.
And we also have a vertical offset. So those are the relationship between the distance of the screen to the front of the lens and also from the top of the screen to the center of that lens. And each lens is kind of like a lens on a camera where we have a zoom in and a zoom out. And we basically, that will give us our min and max throw distance.
So what happens if we're outside of those ranges?
We simply can't either fill the screen or we can't get the image to fall onto the screen.
And I've seen both of those happen. So it's great to calculate what the throw distance is for your projection and screen to maximize what the projector and screen can do. So let's talk a little bit about screens and screen materials. So I know there's a ton of different screen materials out there. Does that have a really big impact on what the projector can do?
Absolutely. So there is a relationship between that screen and that projector. We need to make sure we pick both of them together, not separately. So we often look at just doing a screen with a small amount of gain to match, because many of the projectors we have today are sufficient brightness. As we increase our screen size, we may increase the gain of the screen, but you don't want to increase the gain of the screen too high because then you're going to bring in some visual artifacts. So what we generally do is say, if the screen is getting large, then we have to go to so much gain, we'll actually go back and reevaluate the projector. So we talk about that circle of evaluation. We go back and look at the projector and say, we need to increase this light engine to better match the size of the screen without increasing the gain.
Got it. And what does gain mean in a non-technical form?
So basically what you're doing is you're taking a flashlight and throwing it off of that screen and having it reflect back at you. If you have a screen with no gain, basically light hits it and just comes back. What we do is we work with manufacturers that add a little bit of an optical coating to the front of that screen. What happens is when that light hits it, it's actually increased a little bit, and that's the gain that we get back.
So it adds more reflection.
Correct.
To the screen. Excellent. I learn something new every day. That's great. So when we look at screen sizes, we look at the projector, we talk a little bit about different throw distance. We talk a little bit about different aspect ratios. What about when we go to speakers behind the screen, like we mentioned before? Does that have an impact with the brightness or the actual screen itself?
It does. So once we select that screen material, we'll select it based on it not being perforated. And when we talk about screens that are acoustically transparent, we're talking about it being perforated or weaved. So we can put those speakers behind it and the sound can still come through. When you do that, you're putting tiny holes or little areas where the weave is open so that sound can come through. But what happens is that means some of the light is then bypassing the screen and not being reflected back to you. So sometimes we will increase the gain of that screen to compensate for the loss that we have with the acoustic transparency.
So when you're looking at all these different variables, you're trying to give the customer the best experience. So we will figure out the proper gain, if it's acoustically transparent, the actual width of the screen for the room, the throw distance as well, and then the placement of the speakers behind that screen.
Absolutely.
Okay.
Every piece of that puzzle is figured out ahead of time before we go to install.
So with projectors and televisions, you know, we have wiring and all these different variables that we have to add to the system. How important is HDMI? How important are the speaker wires?
Well, with every iteration of HDMI, we're putting more bandwidth down that cable. So basically it just means we're taxing that cable harder and harder with each increase of the HDMI spec. So we have to make sure that we pick a cable that is of the quality that it can pass that signal.
And most of the cables we have actually have a rating to them. So they'll say that we could do 4K, we could do 8K, we could do 120 hertz cycles. So those ratings, we need to follow those ratings when we're selecting the projector and so forth and so on, correct?
Correct. And then we have, like you said, right on the cable, it may even give it in gigabits per second. That bandwidth that it can handle might say 18 gigabits per second, might say 48. And as you increase the length of that cable, we definitely need to increase the quality of that cable because there is a loss of signal over that distance.
And then what about speaker cabling? Does the gauge matter, the quality of the copper matter, all those different variables?
It does too. So we want to make sure we use a high strand count of speaker wire. And the longer the distance, the greater we want to move and gauge. So we generally start at a minimum of a 16 gauge, but then in a high quality home theater, we might be using 14 or even 12 gauge.
Okay, so when we're looking at those different variations of HDMI cables, I know in the gaming community, they're all about bandwidth, right? They want the most amount of bandwidth. Is that going to play particular if a customer wants something that's going to be a gaming console to connect to the projector system or home theater? Do we want to make sure that that cable could pass everything?
Yeah, so we talked earlier about how we want to get that evaluation of what the client's needs are for the space. If they want to use the space for gaming, it is important for us to know because those are some of the most bandwidth intensive devices we have out there. You know, we talk about 4K, and many people just talk about resolution, but we haven't even brought into account when we talk about things like frame rate, refresh rate. And most of the TV we watch is, 2430 or 60 hertz. Gaming can be up to 60 and then all the way up to 120.
Yeah, so I know gaming does a lot of taxing. What about our streaming services like the Rokus, the Apple TVs? Do they have the same impact when we're looking at cables and picking cables and stuff like that?
They do, but they are going to be capped at that 4K 60. But they are still going to push that 18 gigabits per second.
Okay. Yeah, so that's very important in the world of HDMI. And then we have, movie servers, Blu-ray players, they're all at that 18 gigabit or higher level as well. So HDMI seems like it's a very important part of what we're doing when we're doing a home theater. Now, we talked a little bit about the speakers, we talked a little bit about subwoofers, we talked about projectors. What about the processor or receiver or amplification? How important are those particular things?
So when we look at the system design, we have our inputs coming out over here, and we have all of our outputs over here. And that middle section of it is most of the part that we don't talk about too much, but it's the part that we in the middle kind of have to understand because we have to take all of those sources and all of those displays and make them work together. So that middle part of the chain is extremely important because we have to make sure it doesn't create some sort of constriction point or create incompatibility between the sources and the displays.
So when we were looking at it, at what point do we figure out, hey, I want to do a receiver, a really big receiver, or do I want to do separates? And
so from the standpoint of that HDMI signal, most of the time a receiver and if it's just a preamp processor, will be very similar. It's when you start talking about the amplification capabilities that we start to move away from a receiver to separates with an external amplifier.
So amplifiers, we know, in general, will typically give you better performance. In a home theater, we're not necessarily cranking away at it. like we would a musical system. But having a secondary amplifier will give us that ability to get really low and extremely high, all without taxing necessarily the receiver or whatever it may be, correct?
Correct. So sometimes we even do many amplifiers, and each one of those amplifiers is going to have their own power supply.
Yep.
When you're in a receiver, all of those amplifier channels are sharing that power supply. So when there's a hit in the room, and all those speakers need to play simultaneously at a very high level with a sharp transient, your receiver is going to bog down a little bit. When we have separate amplifiers, each with their own power supply, that system will just keep going.
And I know in my experience and with the help of Gabe is that we've had customers that come in and say, hey, I have a receiver. It sounds like when I turn it up, my subwoofer's almost overpowering the room and the speakers really can't keep up. Well, typically what happens in that particular case is the receiver's running out of headroom.
Correct.
And when it runs out of headroom, that's where an amplifier will come in and it'll probably fix the problem and give you enough power for the speakers to elevate above what the subwoofer levels are doing. Especially in spaces in which we're utilizing more than just 2 subwoofers. We're using 4, 6 subwoofers. We need to have enough power that the speakers can definitely output the same demand that the subwoofer's putting out.
Correct. And sometimes, as you mentioned earlier about having the 3 primary speakers in the front, sometimes we'll just put external amplification on those. Just get those primary channels lifted first, and then approach the rest of the system later.
So really when we design systems, it's almost like a customized system that we're designed for every person. It's not necessarily the same, or cookie cutter as they say.
Absolutely. Every room is a custom design.
Okay, very good. And when Gramophone comes into a space and get you involved, we know before we put our first speaker wire or our first HDMI in the cable, that system's going to function at a certain level. It's going to meet or exceed the expectations of the client. And we're going to make sure we have a stability needed or necessary for that system to give you a long enjoyment throughout the years of owning that system.
Yeah, and while every one is a custom install, we're taking all those years of experience, funneling it together to come down to the next system.
And I know when we take our years of experience, we have the ability of adding what is called DSP to the system. That DSP is essentially taking the components in which we have and giving the most, or giving it the most ability to perform at a very high level. Does Gramophone help with DSPing the system? What's our stance on that?
Yeah, so we will do an audio calibration of the room and we'll apply DSP to it. DSP is not a solution to a problem. If we don't pick the right speakers for the right space or don't design the space properly, DSP isn't going to fix all of that. What we do is we just use DSP at the very end to just kind of maximize that speaker installation to your acoustic space, because every space is unique, and that's where the DSP comes in.
So when we go through that DSP process, the pros are we're going to maximize the space. Sometimes we notice that even we DSP the system, you may lose a little bit of volume, but you're gaining a ton of effectiveness or a ton of enhancements with direction and time alignment and all that stuff. Is that traditional with DSP?
That does. That is one of the, what seems like an unintended consequence. And some of it is that your ear just doesn't hear the distortion anymore that was there, or a speaker that was being driven too hard or something like that. So it feels quieter, but ultimately the entire system has more clarity.
Right. And clarity is essentially what we're after when we're dealing with a home theater system. Guys, we talked a lot about building a home theater as far as the AV components go today. We mentioned a little bit about speaker placement, the differences between 5.1, 5.2.4, subwoofer placement, projectors versus televisions, projector throw distances. So there's a ton of stuff that we've covered today. Gabe, I thank you for your time.
Thank you for having me, Tom.
It's awesome to have you out here on YouTube for the first time. Guys, thanks again for watching our video. As always, don't forget to like and subscribe below and hit the notification bell as well. We also want to point you to the direction of our www.skybygramophone.com, and you can come check out one of our 5 various locations, one in Cockeysville, which is our kitchen design center. We have 2 AV stores in Timonium. We have one in Columbia and one in Gaithersburg. Thanks again.